Today we're going to start chapter 8, which is on page 357, and this is about confidence intervals. So the purpose of studying statistics is because we want to know about the population. So we have a population, and there are some numbers, the parameters that we want to know about them. So to know about these parameters, we're going to collect a sample, and with that sample, we're going to be able to compute some numbers. Every number is a statistic, and we can compute the mean, we can compute the standard deviation, we can compute the proportion, and everything that we do in this part is known as descriptive statistics. Then we learn about checking normality, because many of the procedures that we're going to follow only apply if you are dealing with a population that is normally distributed, or whether the sample size is greater than 30. Maybe you remember that. And greater than 30 for the sample size, or the population is normally distributed. The population is normally distributed. The population. So once you check normality, and to do that we have histograms, or we can use the normal quantile plots that we learned in a previous lecture. So once you have the normality check, then you're going to be able to proceed with the next steps. So what is the purpose of doing this? We want to know about the parameters. So we're going to need point estimates. So for example, if you want to compute the mean of the population, if you want to know about the mean of the population, we're going to use the mean of the sample. So the mean of the sample is going to be my point estimate for the mean of the population. If I want to know about the standard deviation of the population, then I'm going to use the standard deviation of the sample as my point estimate for the standard deviation of the population. Also, if I want to know about the proportion of the population, I'm going to use the proportion of the sample to learn about the proportion of the population. So my point estimates are just numbers, single values. So we can find the definition of point estimate on page 358, and we have the definition there that says that a point estimate is a single number, that is used to estimate the value of an unknown parameter. So this is the purpose of studying statistics. We want to know about the population parameters. So the first step is the point estimate. Then we need to compute a margin of error. And to compute the margin of error, we're going to use sampling distributions. So we learned about sampling distributions on the last chapter. So we're going to use sampling distributions. We're going to use a different distribution depending on what we are trying to find. For example, if we were trying to find about the mean, so if the purpose is getting the margin of error for the mean, we're going to use either the normal distribution, or we're going to use a new distribution. We're going to use the student t distribution. This is if you want to know about the margin of error for the mean. So we're going to create our parameter responses by using a point estimate and a margin of error for that point estimate. So if you want to know about the standard deviation, if that's the purpose of your investigation, then we're going to use a different sampling distribution. We're going to use a chi-square sampling distribution. For what? To compute the margin of error for the point estimate or the standard deviation. Finally, if you want to know about the proportion, margin of error for proportions, Then we're going to use another distribution. We're going to use the normal distribution. The normal distribution. So this is a summary of what we're going to do in chapter 8. This is about just computing point estimates for every parameter that we are interested in, and then computing the margin of error. So at the end of the day, we're going to have our point estimate plus minus a margin of error. So either the mean, the standard deviation, or a proportion. It's going to be sorry, we're going to use the estimates. So we're going to use p hat plus minus or margin of error. So this is the way that we're going to compute an interval for the mean of the population. This is the way that we're going to compute an interval for the standard deviation of the population. And this is the way that we're going to compute an interval for the proportion of the population. So in every problem that you're going to solve in this chapter and in your exam, you're going to need to provide me with your point estimate. That is very easy to compute. You know, you can use R to compute the mean. Sometimes you are given the mean, so you just need to find the margin of error. So you provide the mean, the standard deviation, or the proportion of the sample, plus minus a margin of error that is going to depend on the distribution that you're going to use, the sampling distribution that you're going to need to use. So let's continue with this. So the next thing that we're going to do is we're going to talk about some terminology that we need to use when we are dealing with confidence intervals. So another way to say the same thing about getting the confidence intervals is the confidence interval is just a lower limit that we're going to find, a lower limit for the parameter that you are looking for. So for example, you're going to have a lower limit for the mean, and you're going to have an upper limit for the mean. If you are looking for the standard deviation, you're going to find a lower limit and an upper limit for the standard deviation. And finally, for the proportion, you're going to find a lower limit and an upper limit. So this is one way to provide the answer by using this notation, and the other one is the one that I just mentioned before. You provide the estimate plus minus a margin of error. So for the mean, this is the one. For the standard deviation, this is the next one. And finally, for the proportion, this is the one. So there is a relationship between the lower limit, the upper limit, and margin of error. So we're going to see that later. So there are two ways to show your response. Okay, so I'm going to summarize here what we're going to do in this chapter. So if you are trying to learn about the mean, so again, I'm going to emphasize this. I'm telling you this many times. So the point estimate is the mean of the sample for the mean of the population. So this is the parameter for the population that we are trying to find. And for the margin of error, or lower upper limits, which is the same thing, we're going to use a sampling distribution. So the sampling distribution for the first one, we said there are going to be two possible sampling distributions. One is going to be the normal distribution, and the other possibility is the student distribution. So this is for the mean. So these are the sampling distributions for the mean. Then for the standard deviation of the population, the point estimate is going to be the standard deviation of the sample. And for the margin of error, or to compute the lower and the upper limits, we're going to use the chi-square distribution. And finally, for proportions, you just need to compute the proportion of the sample, and then you're going to use the normal distribution. So keep this in mind. This is going to be the general approach for you to solve these problems related to confidence intervals. So all of these are sampling these distributions that you're going to use to compute the margin of error or the upper and the lower limits. So we're going to have some terminology, as I mentioned before. So basically, we're going to start talking about a confidence interval. Let me write the definitions. So on page 360, we have the following definitions. The first one is that a confidence interval uh, is an interval that is used to estimate the value of a parameter. The value of a parameter. So that's the confidence interval. It's just a lower limit and an upper limit. So these are going to be our confidence intervals, a lower limit and an upper limit. But we need to attach a certainty, a degree of certainty to every confidence interval. We can say any number as a lower limit and any number as an upper limit, but that is not going to the way that we need to work. We need to attach certainty, a degree of certainty, a number that is going to tell something about that confidence interval. So that's the next definition. So we're going to use the confidence level, that's another term, is going to be a percentage between 0% and 100% that measures the success rate of the method used to construct the confidence interval. So if you have a confidence level of 95%, that means that if you run the process or the procedure many times, 95% of those times your parameter, the parameter that you are looking for is going to be contained in the interval. Or in other words, 95% of the interval that you're going to find are going to contain the true parameter. So that's another way to say that. 95% of the confidence intervals that are computed will contain the parameter. So if you run the experiment, if you collect 100 samples and you compute the mean and you get the confidence interval for the mean, 95% of those samples, 95 samples, are going to contain the true parameter mean for the population, and 5% are not going to contain that parameter. So if you want more confidence, you need to increase the confidence level. So that is going to be impacting the size of the margin of error. So now let's talk about the computations, about the procedure. So let's talk about that. I'm going to scan the notes later for you to have them. So this is going to be in the same way that we have been working so far. So The way that we're going to proceed is going to be slightly different from the way that is described in the book, because the book goes first finding the z-scores, and then with the z-scores they use sampling distribution. So we're going to try to do it in a more simple, simpler, in a much simpler way. So there are going to be two ways to find a confidence interval. Confidence intervals for the mean. That's going to be the purpose of this section. This is section, there are two sections. Section 8.1 and section 8.2. Those are going to be our confidence intervals for the mean. So today we're going to cover only these two sections. So in the first case, that's the rare case, is rare. So the standard deviation of the population is no. Is rare because usually we don't know anything about the population. That's the purpose of doing this work. We don't know anything, but there are cases where they say we have some values from previous research, so you can use some standard deviation for the population. So this is a rare case, but it happens. So the other case is when you don't know anything about the population, so the standard deviation is unknown. So there are two different procedures. So in the first case, we're going to use the normal distribution as a sampling distribution. And for the second case, we're going to use the student t distribution. So most of the problems then are going to be solved with the student t distribution, because most of the time we don't know anything about the population. So, but you need to read carefully. Sometimes the standard deviation of the population is given. Remember, the standard deviation of the population is not the same as the standard deviation of the sample. So be careful, read carefully. And if you read carefully, you're going to solve all the problems very well. So let's start then with section 8.1. Section 8.1 starts on page 350A, but the actual contents related to building the confidence interval starts on page 363. So we're going to have 362. So check page 362 is where the confidence interval construction starts. So let's start with the assumptions. So the assumptions for this case, which is the section 8.1, is about confidence intervals for a population mean when the standard deviation is known. So we want to know the mean, but we know the standard deviation of the population. So this is our population. So the mean is not known, but the standard deviation is known. So we're going to collect a sample as usual. We're going to have a sample, and we're going to proceed immediately to compute the mean and the standard deviation. So we compute the point estimate. So that's our first step. So later we need to know the confidence level of the interval that we want to build. So with the confidence level, you're going to compute alpha, which is the significance level. And with that information, then you're going to go directly and compute your limits. You're going to compute the upper and the lower limits for our parameter. And that's it. So for this case, so alpha is going to be usually 1 minus conf, the confidence level. The confidence level is expressed as a fraction of 1. So we need to write here over 100. Usually the confidence level is divided by 100. And once you have alpha, your upper limit is going to be computed by using R. So using R, this is going to be very simple. We're going to compute Q norm. So that means that we are using the normal distribution. So this is my sampling distribution because I know the mean, I know the standard deviation of the population, so the normal distribution. So we're going to use Q norm. You're going to enter 1 minus the value for alpha divided by 2, comma, you're going to enter the mean that you computed, the mean of the sample. Then you're going to enter the standard deviation of the population that is known divided by the square root of the sample size. Remember, that's the way that we computed the standard deviation of the sampling distribution. This is the mean of the sampling distribution. The lower limit is going to be just Q norm of alpha over 2, comma, we enter the mean of the sample and then the standard deviation divided by the square root of the sample size, and then we report. So the report, the answer, the final answer for this problem is going to be just writing the lower limit, then you're going to write less than mu less than the upper limit. If you want to know the margin of error, the margin of error is going to be the upper limit minus the mean. That's the margin of error. So what is the margin of error in terms of the computation that we are doing? So if you have your population, this is the population, and we are saying that the mean is here. We are trying to use a sampling distribution where we have here the mean of the sample, then we have the upper limit here, the lower limit here. This is the upper limit, this is the lower limit, and the difference between the mean and the upper, or the mean and the lower, this difference, that's the margin of error. This distance between the mean and the upper limit, or the mean and the lower limit, that's the margin of error. So we're going to start solving exercises. So most of the time is just keep an eye on every single sentence in your statement, read carefully, and then you're going to decide what kind of problem you have, and with that you're going to be able to get your interval, your confidence interval. So we're going to start solving example 8.4. So we're going to solve example 8.4. So 8.4 is the example that we're going to solve is on page 363. So we're going to read very, very carefully. So we have, this is our problem. Let me see, I'm going to increase zoom. I'm going to zoom in. Okay, I hope you're going to see now the problem. Okay, we have the mean test score for a simple random sample of n equals 100 students was x bar equals 66.30. The population standard deviation of test score is sigma equals 15. Construct a 98% confidence interval for the population mean, test score, mu. So that's our problem. So your book suggests first checking the assumptions. The sample is a simple random sample. We read that. It's written in here. So you read simple random sample. That's the first assumption. The second assumption is that the size of the sample is greater than 30. So that means that there is normality, or you can assume normality for the sampling, for the purpose of using a sampling distribution. So let's follow the steps I just mentioned before. So we're gonna have, let me just reduce the, okay, so we're gonna have, I'm going to write those the important things. We read simple random sample. And they also said that n equals 100. So that means that n equals greater than 30. So you can, this is a test of normality. So we were checking normality to be able to use a sampling distribution from the ones that we learned from previous chapters. Then they say that the population, so you need to read carefully, the population standard deviation sigma equals 15. So they say this is the population standard deviations. Sometimes they are not going to say that. They are going to give you this symbol, the Greek letter S, sigma. So that means that they are giving you a parameter. So if they give you sigma or other Greek letter, they are giving you information about the population. If they don't give you this, if they give you S equals 15, then they are giving you values from a sample. So then we're going to have, we need to compute the 98% confidence interval. So immediately we're going to be able to find alpha. So alpha is 1 minus the confidence level over 100. So the confidence level is 1 minus, so the confidence level is 98 over 100. So this is just 1 minus 0.98. So alpha is going to be 0.02. So alpha equals 0.02. This is a very important parameter. If you fail to compute alpha, then the margin of error is going to be not correct. So also they are giving you information about the sample. So they are giving you the mean of the sample. The mean of the sample is 67.30 is given. So sometimes this value this value is given. Sometimes you need to compute the value if they give you a data set. So if you are given a data set, so the actual sample, then compute the mean. In this case, they did it for you. So we only need to apply our formulas. So we have our sampling distribution. So we're going to have here the mean. Then we're going to find the upper and the lower limits. And that's it. So the only information that they are giving you is that this area is 0.98. So that's the 98% confident interval. So we're going to start with our upper limit is going to be, I gave you the formula is Q norm of 1 minus alpha over 2 x bar sigma over the square root of n. So that's the formula. So let's do that. So we're going to have Q norm of 1 minus 0.02 over 2. Then we're going to write comma 67.30 comma. Then we're going to write 15, which is the standard deviation of the population. So it's going to be 15 over the square root of the sample size. So they are talking about 100 students. So that is going to be my upper value. So I'm going to write here the answer. Also, I'm going to write the same thing for the lower limit. So I'm going to use Q norm. Now it's going to be alpha over 2. The rest is going to be the same. So it's just standard deviation of the sampling distribution. So the lower limit is going to be Q norm of 0.02 over 2 comma 67.30 comma 15 over the square root of 100. So let me use my R console to find those values, and then you're gonna see the interval that we're looking for. So let's change to the R console. So I have Q norm of 1 minus 0.02 over 2 comma 67.30 comma 15 over the square root of 100. So this is going to be 70.78. I'm going to use this one. I'm just going to remove one minus, and that gives me the lower limit. So I have 63.81048 for the lower limit and 70.78 for the upper limit. So let me write that back on my notes. So I'm going to write just the answer. So the lower limit 63.81048 less than and I have here 70.7895.2. So sometimes you need to find the margin of error. Margin of error is just going to be capital E. It's going to be my upper limit minus X bar. So it's going to be 70.789052 minus 67.30. So the margin of error in this case is going to be 3.48 and 9522. So I'm going to solve another problem. So and then you're going to be able to play with this. So we're going to solve now example A.5, which is on page 365. Page 365. So let's see. So we have here, let's see if you can see it. Okay, I have this problem here. So let's increase the... Okay, we have here that a machine that fills cereal boxes is supposed to put 20 ounces of cereal in each box. A simple random sample, okay, again, so there is information here that is important. A simple random sample of 6 boxes, so now n equals 6, is found to contain a sample mean of 20.25 ounces of cereal. It is known from past experience that the field weights are normally distributed, so this is another important thing, are normally distributed, so they are telling you that the population is normally distributed, is normal, so it doesn't matter that n equals 6. They are saying that normally distributed, so we don't need to have n greater than 30. So this population is normally distributed with a standard deviation of 0.2 ounces. So they don't write here the Greek letter sigma, but you need to understand that they are talking about the population. So they are talking about the population, so this is going to be your sigma. So construct a 90% confidence interval for the mean field weight. So again, this is just writing the information in our notes, and then we're going to proceed with the computation. So let's see. So we have the information that is given. Then is that we already read that it's a simple random sample. Simple random sample. We have n equals 6, but the population is normally distributed. The population is normally distributed. So they say that, so that means that normality is fine. So we check normality, and the assumptions are met. So then they say also that the standard deviation from past experience is 0.2. So we're gonna now we're gonna build a 90% confidence interval for the mean. So that's we're gonna construct. We're gonna build a 90% confidence interval for the mean. So we need alpha. So alpha is gonna be 1 minus the confidence level. So it's 1 minus 0.90. So alpha is just 0.10. So this is important. So we also know that the sample has a mean of 20.25 ounces. So if you are not given this value, remember you need to compute it from the given data set. So then you just need to again, we're gonna have our sampling distribution. We have the mean here. We're gonna compute the upper value, the lower value, the lower limit, and again now this area is 0.90. So our upper value is just Q norm of 1 minus 0.1 over 2, comma, now we have a mean of 20.25, comma, then we have the standard deviation of the sampling distribution is just 0.2 divided by the square root of 6, because we only have a 6, the size of the sample is just 6. So that's for the upper limit. For the lower limit, it's just going to be the same thing, but the first value is going to be just 0.1 over 2, then 20.25, 0.2 over the square root of 6. So we're going to have an upper value, a lower value by using R. So let's move on to R now. So this is what we're going to do now. So we have Q norm of 1 minus 0.1 over 2. The mean is 20.25. The standard deviation is 0.2 over the square root of 6. So we get 20.3843. We repeat the command and we remove 1 minus, and we get the lower limit, which is 20.1157. So that's the result of using our R console. So this is going to be very easy for you in the exam. So let's write the answers here. So the lower value is 20.1157. The upper value is 20.3843, and we write the 90% confidence interval is going to be for the mean is just mu is greater than 20.1157 and is less than 20.3843. 43, and again you can find the margin of error by subtracting the upper value 20, 38, 43 minus the mean of the sample, which is 20.25, and you're gonna find 0.1343017. So that's the margin of error for this confidence interval. So the answer that I expect from you in the exam is this. So that's what we need to find. One more problem. So we have example 8.6. So example 8.6 on page 366. So essentially we're going to use the information from the previous problem. The only thing that we're going to change is the confidence interval percent. So instead of 90%, now it's going to be 99%. So, and we're going to see the difference of the margin of errors. So essentially it's just the same problem as before. So same population and sample as in example 8.5, but now we're going to use a 99% confidence level. So the only thing that we're going to change is alpha. Alpha is going to be 1 minus 0.99. So alpha is now 0.01. So alpha is 0.01. So the only thing that we're going to change from before is the computation of the upper and the lower limit. So the upper now is going to be Q norm of 1 minus 0.01 over 2, and the rest is going to be the same. So the only thing that we are trying to find here is the difference of the margin of errors for these two problems. So you're going to see what happens with the margin of error when you increase the certainty of your interval, when you increase the confidence of your interval. So the lower limit is going to be just Q norm of 0.01 over 2, 20, 25, 0.2 over the square root of 6. So this is going to give me the lower limit. So let's use R. The only thing I need to do is just repeat the commands and just change the value for alpha. So if I repeat the previous one, instead of 0.1 is 0.01, and then I'm going to remove again for the lower limit. So I have my two limits now. So my lower limit is 20.03 and the upper limit is 20.46. So let's write that down and compute the margin of error for this exercise. So we have the upper limit being now 20.46, 0.32, and the lower limit is going to be 20.03, 968. So the confidence interval, the 99% confidence interval is going to be 20.03968 less than the mean, less than the upper value. So that's my confidence interval, my 99 confidence interval. And to compute the margin of error, you know that you need to subtract the mean from the upper value. So the margin of error for this problem is going to be 20.46, 0.32 minus 20.25. So you're going to find that in this case we're going to get 0.2103156. So let's summarize the results. When you have a 90% confidence interval, the margin of error was 0.13. So 0.1343, and when you have a 99% confidence interval, then now your margin of error is greater. So you have more error, but by having more error, you have more confidence in that you're gonna get the mean of the population in the computed interval. So this is what you need to know about computing confidence intervals. So now you're gonna solve some exercises. So let's see. Let me see what our exercises are. So we're gonna move to page 372. In page 372 we have exercises 43, 44. Yeah. Okay, so there are 4 exercises. You're gonna try to do those exercises. Now I'm going to stop the recording for you to do those exercises, and I can wait for you to solve at least one and give me your answer. If you solve one or if you solve 2, then you get your points for class work. If you need to do it at home, then you need to solve the 4 of them. So you're gonna solve from section 8.1 exercise set on page 372. You're gonna solve exercise 43. Let me see, 43. You're gonna solve only part A. And 44, you're gonna solve only part A. If you solve everything, then you need to solve at home 2 more exercises, 47 and 48, and you're gonna solve part A, part C, and part A, and part C. So solve those problems. I'm going to project now 43 and 44 for you to see them. You just need to solve part A, 43 and 44 now. Show me your answers. You can use the chat feature to show me your answers, and in that way you comply with your classwork. You get your points. So let me just show you 43 first. So let's increase the zoom size. So I'm going to, that's 43. So try to copy the most important information to stop the recording. So that's 43, and we have 44 here. So I'm going to stop. I'm going to pause the recording, and then you're gonna have time to solve these problems and send me your answers via chat. So let me stop the recording. Okay, to finish section 8.1, we need to give a look about finding the necessary sample size. So when you're going to conduct an investigation, a research, a survey, sometimes you need to know in advance what is the best sample size for you to get the margin of error that you are expecting. So to do so, you just need to follow a formula that is on page 369. So on page 369, your book provides the following formula. So you have n is going to be z over alpha over 2 times sigma over m, and this is going to be square. So what are these values? Sigma is the standard deviation of the population, and m is going to be the desired the desired margin of error. So it's what you expect to have at most. So it is the error that you expect to have at most. So to decrease the error, then you need to increase the size because they are inversely proportional. So when you increase the error, then you decrease the size of the sample. If you decrease the error, then you need to increase the size of the sample. So this is the formula. So I'm going to solve a problem just for you to see how to apply this formula. So we're going to solve example 8.7 on page 369. So in this problem, I'm going to project the problem first. So example 8.7. So scientists want to estimate the mean weight of mice after they have been fed a special diet. From previous studies, it is known that the weight is normally distributed with standard deviation 3 grams. So how many mice must be weighed so that a 95% confidence interval will have a margin of error of 0.5 grams? So that's the margin of error, that's the expected margin of error 0.5. So we want to know how many mice do we need to incorporate in our study, in our sample. So let's solve this problem by using the formula that I just gave you. So in this problem then, the standard deviation of the population from previous studies is just 3 grams. The margin of error, M, is just 0.5 grams. So, and then we have the confidence level that we are expecting to have in our confidence interval is 95%. So from here you can compute alpha. Alpha is just going to be 1 minus 0.95. So alpha is going to be 0.05. So that's the value for alpha. So we're going to compute then the z-score of any value of alpha using R. So it's going to be just Q norm of alpha. If we want the z-score of alpha over 2, then you're going to use Q norm of alpha over 2. So that's the way that you're going to find this z-score. So we want to integrate everything into a single formula. So our formula by using R is going to be N, is going to be a parenthesis, then you're going to use Q norm of alpha over 2, and then you're going to multiply this by the standard deviation, and then you're going to divide this by the margin of error. You're going to close the parenthesis and you're going to square this. So this is the general formula. So this part is just z alpha over 2 sigma and the margin of error that we are expecting. So let's do the computation by using the information that is given. So in this case, n, the sample size is going to be Q norm of 0.05 over 2 because alpha is 0.05. We're going to multiply this by 3 and we're going to divide this by 0.5, which is the margin of error, and then you're going to square the result. So I'm going to use my R console to get the result. So the R console. I'm gonna use parentheses Q norm of 0.05 over 2. Then I'm gonna multiply this by 3 and we're gonna divide by 0.5, and then we're gonna close the parentheses and everything is gonna be squared. So we're gonna get 138. So n is 138.2925. So that's the sample size. So you need to collect information from 139 mice. So you round up this as 139 mice that you need to investigate. So now we're gonna start the next section. So section 8.2 is more of the same. So with the difference that in these problems, in the next problems, we are not going to know standard deviation of the population. So we start from scratch with no information from previous studies. So let's do that. So let's see. So section 8.2 is about confidence intervals for a population mean, for a population mean, and in this case the standard deviation of the population is not known. So this is the common case. The previous case that we just were on is the rare cases. It's usually not what usually happens. So in these problems, we're gonna follow the same methodology. So I'm giving you always the same methodology. So we're gonna have a population. So we want to know about this population. We want to know the mean is our question mark. So in this case, the standard deviation is unknown. So we don't know anything, but we're gonna collect a sample again. We're gonna have our sample. So we're gonna be able to compute the mean and the standard deviation of the sample, and we're gonna use now a different sampling distribution. So to get the information about the mean, we're gonna use the student t distribution. The student t distribution is going to be my sampling distribution for the mean. So the student t. So now I need an information. It's going to be degrees of freedom. It's going to be those are going to be computed by subtracting 1 from the sample's size. So degrees of freedom is going to be the input value that our student t distribution requires. So, and we need also, again, from the confidence level, we need the significant level, and with this information, we're going to be able to use the student t distribution. So we're going to use a Q T command in R. So it's going to be 1 minus alpha over 2 comma n minus 1. That's the function that we're going to use most of the time. So, and we're going to multiply this by s over square root of n, and by doing this, this is going to be equal to the margin of error m. So this time we're going to compute the margin of error. And once you have the margin of error, then you just need to provide the upper value. It's going to be just x bar plus margin of error, and your lower value is going to be again x bar minus the margin of error. So at the end, you're going to be able to provide again a confidence interval in this way. So let's solve a problem, and then you're going to be able to play with this. So there are assumptions. Remember the assumptions to use these problems is that we have a simple random sample. These assumptions are on page 379. A simple random sample, and the other assumption again is that the population is greater than 30, or that the population is normally distributed. If we satisfy this condition, then we're going to be able to get this confidence interval. So we're going to solve an example, and then I'm going to give you a couple of problems to complete your classwork for today. So this is example. This is going to be example 8.12 on page 380. It's about chocolate cookies. So let's project the problem first. So remember, we need to read carefully the problem, because sometimes I'm going to give you problems that you cannot solve. So you just need to say, I cannot use my sampling distribution because I don't have enough information. So I have this problem. A food chemist analyzed the calorie content for a popular type of chocolate cookie. Following are the numbers of calories in a sample of 8 cookies. So we have the calories of 8 cookies, and we're going to need to find a 90% confidence interval for the mean number of calories in this type of cookie. So we have a simple random sample, but we need to check whether this sample is following shows normally distribution behavior. So to do that, your book suggests to do a plot. So we're going to do our own plot by using our techniques that we have learned so far. So we have the information that is given first. I'm going to write them. So we know that this is a data set, so I'm going to use R. I'm going to enter the data set because now we need to compute the mean and the standard deviation. So the values that are given are 113, 114, 111, 116, 115, 120, 118, and 116. So we're going to need to check normality by creating a histogram or by using Q norm and Q line. So these are the ways to check normality. Remember, we want to check normality because the problem doesn't say that the data set is, or the sample is coming from a normally distributed population. So that's a first step. Then we need to find the mean. We need to find the standard deviation. So to find the mean, we're going to use mean of x, so in R. To find the standard deviation, we're going to use SD of x. N is given, so N is just 8 cookies. and the confidence level that is required is 90%, 98%. So let's see, is 98%, yeah, 98%. So alpha is going to be just 1 minus 0.98. This is going to be 0.02. So alpha is 0.02. From the sample size, we're going to find degrees of freedom because we're going to use a t-distribution. So degrees of freedom is just n minus 1 is going to be 7. So those are going to be our degrees of freedom to use the student distribution. Okay, so let's proceed with the computation. So remember, we're going to find the error m. The error m is just qt. So we are changing now the name of the distribution. Instead of q norm, now we're going to use qt. Remember, the formula is just 1 minus alpha over 2 comma degrees of freedom, and we're going to multiply this by standard deviation over the square root of n. So that's the formula. You need to have this formula in your formula sheet. This is important. So for this problem, it's going to be just qt of 1 minus 0.02 over 2 comma degrees of freedom 7, and then you're going to multiply this by the standard deviation that we don't know yet. We're going to compute that value and we're going to incorporate that value into our computation. So the standard deviation, I don't know yet the standard deviation, but we're going to divide that by the square root of n, which is 8. So let's do that. So we're going to start using our R console to be able to do the computations. So we're going to start first entering the data set. So it's just 113, 114, 111, 116, 115, 120, 118, and 116. So you can check the length of the set to see whether I enter a value. So I need n equals 8. So we can use histograms as I mentioned before. So you can have here a histogram. Looks normal. And you can also use QQ norm and QQ line. So you're going to do that at home. So let's just finish finding the margin of error. So the margin of error m is just, sorry, I need first the mean. The mean of x is, the mean, we don't need the mean for this problem, but we need to, just for completeness, we're going to compute the mean. It's just 115.375 by using R, and the standard deviation is just the standard deviation of x is 2.85, 2.82, 52, 67. So that's the value that we need for our computation. So we're going to be able to compute now the margin of error is going to be qt 1 minus 0.02 over 2 comma degrees of freedom 7 degrees of freedom times, now the standard deviation is just 2.82 5 by 2.82 by 269, and we're going to divide that by the square root of 8. So the margin of error is gonna be in this case is the margin of error is 2.994604. So the upper limit is gonna be the mean. We needed the mean. I totally forgot we needed the mean. So the mean is just 115.375 plus the margin of error 2.994604. So my upper value is gonna be 118.3696. My lower value is gonna be the mean minus the margin of error. So is this computation with minus here. So the lower limit is 112.3804. So I'm just copying this information for your notes. So, and you can see those values now here. So the mean that I computed from R is here. Then the standard deviation is here. Then this is my formula. Now I know that this value is S from R. So the standard deviation. So I wrote 2.8252, but I used all the figures here. So then I got from R my margin of error, then I added to the mean and I subtracted from the mean. So these are the values of the final answer. The 98% confidence interval for the mean is just 112.3804 less than mu less than 118.3696. So this is the answer. So I have my confidence interval for the mean. So finally, you're gonna solve from section 8.2 exercise set on page. Let me see the page. So you're gonna solve from page 386. You're gonna solve two problems. You're gonna solve problem 31. So 31. Problem 31. You just need to solve part A. Then problem 37. 37 is a very important problem because you're going to have a problem like this in your exam pretty soon. So problem 37, you're going to solve part A and B. Part A and part B. So I'm going to project now for you to get the problems if you don't have your book at home. So let's increase here. Okay. I hope you can see now. So 31 is here. Just take a screenshot or something like that. I'm going to project now problem 37. So problem 37 is here. So that's the other problem. So you're gonna solve these two problems and you're gonna send me a screenshot with all your classwork to get your points for this for this section, for these two sections. So that's problem 37. So I'm going to stop now the recording. I'm going to give you some announcements regarding your future exam. Let me see. Let's stop the recording.